This episode of Photonics Hot List is brought to you by Edmund Optics, where custom manufacturing is supported by a comprehensive range of measurement capabilities, including in-house laser damage threshold testing, custom-built industry-leading spectrophotometers, and aspheric stitching interferometry with less than 20 nanometers of uncertainty. Learn more at edmundoptics.com/manufacturing.
Hello, I'm Justine Murphy with Laser Focus World. Let's take a look at some of the amazing things happening in photonics. Detecting neurological diseases like Alzheimer's early can make all the difference when it comes to treatment and successful outcomes. That's well understood. What's not quite so well understood is just exactly how the brain's neural networks operate in real time. But researchers are now cracking that code. A team from the University of California, Davis has developed a two-photon fluorescence microscope that captures high-speed images of neural activity at cellular resolution, offering insight into how different neurons communicate and interact. The team's new design, detailed in the journal Optica, involves adaptive sampling. Specifically, it uses a short line of light that illuminates only specific parts of the brain where the neurons are active. This allows a larger area to be sampled at once, which significantly speeds up the process. And by focusing solely on specific regions of interest, the total light energy deposited to the brain tissue is reduced, in turn reducing potential harm to it. Conventional two-photon microscopy approaches are inherently slow, the researchers say, and can damage brain tissue. The team is now working to equip the new microscope with voltage imaging capabilities and ultimately broaden the scope of their neuroscience research. In a photonics industry first, a team from Synopsys has designed a virtual prototyping platform for system-level imaging that's quicker and significantly more accurate than existing setups. The California-based company, which provides silicon to systems design solutions, including for optical designs, automation, and simulations, has developed the Imaging System Simulator, or IMSIM, which brings together all components of an imaging setup, lenses, sensors, and image signal processors to create a comprehensive simulation platform for optimizing any imaging system. The setup involves a series of simulated images at each step in the imaging system chain, allowing image quality assessment throughout the process. IMSIM models geometric, aberration, and diffraction effects while also simulating stray light sources. It involves models of detector effects on imaging with radiometric accuracy as well, and processes those detected images with custom or built-in image and signal processing. The team says the new system's comprehensive virtual setup reduces development time by allowing seamless evaluation of full system performance. Topology has long been seen as a classical phenomenon, but researchers in Germany have discovered it could someday play a substantial role in the quantum realm. A collaborative team from the University of Rostock and Albert Ludwig University of Freiburg paired the topologically robust properties of light with their interference of photon pairs. They found that topology, an abstract mathematical concept first developed to classify solid geometries by their global properties, could potentially be used for the transmission and processing of quantum information. The team's work is based on the Hong-Au-Mandel effect, an interference effect in quantum optics that occurs when two identical single photons enter a beam splitter in separate input ports and later exit the beam splitter together in the same output mode. Using these topological concepts allows the generation of light waves that are robust enough to travel around corners and defects. The researchers say this topologically protected Hong-Au-Mandel interference could be used for applications including quantum computing and time measurements that require attosecond precision. And that's your Photonics Hot List. Be sure to like and share, subscribe to our YouTube channel, follow us on social media, and visit laserfocusworld.com for the latest and coolest news and information. And check out our Following the Photons podcast too, to hear some cool interviews and news impacting the industry. Until next time.